In the following example, we're asked to find the intervals of concavity and points of inflection of f of x equals x to the fourth plus 6x cubed. Well, in order to do this, let's go ahead and take a look at the definition. So looking at the definition, it states that for concave upward, we need f double prime being greater than 0. For concave downward, we need f double prime being less than 0. And recall that points of inflection, well, we can use f double prime of x and set that equal to 0 to help us identify if we've got an inflection point or not. So let's go back to our problem. So what we need to do is find the second derivative. So first, let's find the first derivative, f prime of x equals, well, then it's 4x cubed plus 18x squared, and then again the second derivative, f double prime, is going to be 12x squared plus 36x. Okay, that's not too bad. We're going to start off first by trying to find some values that might be our inflection points. So what we're going to do is we're going to factor out 12x from here. So I'm going to factor out the GCF 12x, leaving me with x plus 3. Again, I'm going to set that equal to 0, and I've got two values for x. In the first case, I've got x equals 0, and in the second case, I've got x equals negative 3. So now what we're going to do is a second derivative test. So let's go ahead and draw out a number line here for f double prime. Alright, and I'm going to put 2 points here. Alright, one will be for negative 3 and the other one will be for 0. So what we're going to do is evaluate our second derivative at a number just before negative 3. So suppose you pick negative 4. Well, plugging in negative 4, you obtain a positive value. Alright? Now let's pick some value in between negative 3 and 0. Okay, suppose we pick negative 1. So plugging in negative 1 into our second derivative will yield a negative value. Okay, good. Now we've got 0, another point that could possibly be a point of inflection. So let's pick something beyond 0. Suppose 1. Well, we plug in 1 into our second derivative, and again we're going to obtain a positive value. So let's take a look here. Negative 3 and 0. Are they points of inflection? Let's think about that. Let's go back to our definition for inflection point to figure this out. So an inflection point states that this is when it changes concavity. This is when the second derivative changes its sign. So going back to our number line, did we change sign? It's pretty evident that we did change sign between numbers beyond negative 3 coming in from the left and at negative 3. So we go from positive to negative, and then when we get to 0, we go from negative to positive. So we actually do have two inflection points at negative 3 and 0 because of the fact that they change sign. So again, we're going to determine our intervals now of concave upward and concave downward. Alright, so what I'm going to do is I'm going to notate here some intervals. So suppose that I put CC up to denote concave upward. And that's going to be, let's see, wherever we have our second derivative to be positive. So that's going to be in this area and this area. So using interval notation, we've got from negative infinity to negative 3 being concave upward, and from 0 to positive infinity. So this is my area for concave upward. Now to check for concave downward, well, again, this is the area where my second derivative is negative. And so again, I see that down in this interval. So I'm going to notate that. So concave downward then will be between negative 3 and 0. So I found my two inflection points. My inflection points are going to be at x equals negative 3 and 0. So these are my points of inflection, and I'm just going to abbreviate here for you. and my interval of concave upward and concave downward, negative infinity to negative 3 and 0 to infinity for upward, and between negative 3 and 0 for concave downward. So this should answer the question that we were looking at. However, again, if we want to justify our answer, well, we'd state that the reason for this being concave upward is because this is where the second derivative is positive, and for the following, the negative 3 to 0 for being concave downward, well, that's where the second derivative is negative. And again, inflection points, because that's the point at which the second derivative changes sign.
Made with DoodleCast Pro.